All right, guys, we're going to now start graphing some other functions besides sine. We're going to start with cosine. We spent 3 days graphing sine, and there was a reason for that. A lot of graphing sine wasn't so much graphing sine as was translating it, right? Moving it left, right, up, down, changing the period, the amplitude, all that stuff. So we spent time more on that, and the reason we really focused on that is because if you can apply those concepts to sine, you can apply them to any trig function. So we'll be able to graph everything to do with cosine in 1 day today, whereas it took us 3 days for sine. So we'll be able to fly through this pretty quickly. But I want to start with the basic cosine graph, okay? And let's actually, before we get into graphing it, let's maybe make a little chart like we made the other day for sine. We'll just kind of do a makeshift one here. So we'll have x and then cosine of x. And since we kind of know that quarter periods are the key to all this, why don't we just stick with our quarter period points for cosine? So I want you to think of your unit circle, right? And those points, 1, 0, right, 0, 1, fill that in, -1, 0, and 0, -1. Now, when we were calculating the sine values and graphing it, we were always looking at the y value on this chart and going around and finding the y values. But if you remember, cosine was your x value. So at 0 degrees, we would be looking at the x value of that coordinate. What is that value? It's 1. So I would have a point of 0, 1. At 90 degrees, we'd be looking at the x value. What's the x value at 90 degrees? It's 0. So I'd put 0 in there and keep on going. At 180 degrees, we would have -1. At 270, we would have 0. And then at 360, we'd have 1 again, right? And you can imagine if we kept going around, those items would repeat. So if I were to plot these, and you know what, we're going to plot cosine first, and then we're just going to plot sine first to get a sense of how they compare. So cosine looks like actually starts above that midline point of y, or midline line of y equals 0. So there's one difference I'm already kind of noticing. And if I count a quarter period over, I'm now at the point 90, 0. Right, I'm at 90, 0. Then I go down to -1, and that puts me at 180, -1. Then I go up to 270. I'm at 270, 0. And then I'm back up here to 360, 1. So if I were to make my graph and connect these, I get this kind of like upside down bell, or kind of like a valley shape here. Okay, almost like a bowl, okay? But you remember, as we said, this is only one period, and I could keep on going. So you can imagine if I kept on going, this graph would go down, and then go back up, and then back down, and same thing in this direction, right? I won't plot all the points specifically, but you should understand, right, that these graphs go on forever and take that general shape. Well, if I'm thinking about similarities and differences between the sine curve and the cosine curve, the sine curve looks almost identical to that, right? It takes that wavy shape. It oscillates between y values of 1 and -1. It works very well with quarter periods. So you might be saying, well, really, what's the difference then? They're identical, right? They kind of look the same. Well, let's graph the sine function. Let's do it in blue and see how it differs. Well, if you remember, the sine function started on the midline, where it looks like the cosine function starts above the midline. So if I'm graphing sine in blue there, the first point would be 0, 0. If you remember, this is just the basic sine graph. Then the next point, if you remember, was 90, 1. The next point was 180, 0. Right, we plotted all these points before, so this shouldn't be anything too new. 270, -1. And then 360, 0. I'll make this one dotted just so we don't get too confused here. Maybe I'll try to make it a little closer, dots, than the one in black. Right, but we also said there that the sine function keeps on going forever too. right? So as we see here, what's happening, right? If I keep on going here, and I'm going to go down in this direction, is what's happening, right, is that the sine function and the cosine function look identical, except it looks like the cosine is shifted 90 degrees to the left, or you could say, that's probably the easiest way to think about it, right? The cosine function shifted 90 degrees to the left, or if you shifted the cosine function 90 degrees to the right, right, if you shifted all the points 90 degrees in the right direction, not as in correct, but towards the direction right, all the points would line up on each other, right? So kind of interesting. So the cosine graph does look different, but it's really just there's an implied shift in it, right? An implied shift in the cosine graph. So that's really an important fundamental concept to understand. But when we graph them, notice when we graphed cosine, it was easiest to start at the point above the midline, right? I'm going to change colors. At this value right here. And we started the amplitude above the midline. So that's going to be one of kind of the key differences, right? So we wrote here, so let's review the difference between graphing y equals sine of x and y equals cosine of x. Well, sine of x starts at, and this is your just regular function, your regular sine function, right? It could be different if we shifted it. But the regular sine function starts at 0, 0, where cosine of x starts at 0, 1. And that's really the big difference, is the starting point. But notice cosine still has that same pattern. We go from a max to a midline to a min to a midline to a max, right? So it still follows that max, midline, min, midline, max pattern that we saw with sine. We're just starting at a different point, okay, in the process here. All right. While the shape looks blah, blah, blah. Yeah, we talked about that. All right, so we can jump right into graphing cosine, okay? And we can start doing some complicated ones because you already know how all those things work together, okay? So let's walk through maybe a couple examples. So we'll graph the function y equals 3 times cosine of 2x minus 30. Amplitude is that value in front of the cosine that's being multiplied, so that would be 3. The period, again, I would find by doing 360 over b, which is 2, which gives me 180. Okay, the quarter period would be 1/4 of that, or 180 times 1/4, which would be 45 degrees. The midline, again, is always going to be 0 unless we shift it. The starting value, I'm going to set the inside equal to 0. So 2x minus 30 equals 0. 2x equals 30, or x equals 15. So that's your starting x coordinate. And is it flipped? No, it is not. It's not flipped. So again, I'm going to start this like I start every sine and cosine graph. I'm going to start by graphing the midline, which, if it hasn't been shifted, is going to be at 0. Now remember, in terms of the y value, the cosine graph starts the amplitude above the midline, not on the midline like sine. So my starting x value of 15, or is 15, my starting y value is going to be the amplitude above 0, which will be 3. Excuse me. So that will take me to a point here of 15, 3 as my starting value, x and y value for this function. So I start at a max. I then go down to a midline point, a midline point. I'm going to add a quarter period. So add a quarter period to 15, add 45 to 15, and that gets me to 60. I'm now at 0. I'm then going to go down the amplitude to -3 and add another quarter period. That gives me 105, -3. I'm going to add another quarter period. That takes me to 150, 0. And then add another quarter period on top of that. That takes me to 195, 3. So again, if we were to continue this curve forever in both directions, it would look identical to a sine function in terms of its waviness, although its starting and ending value would be different. But when we graph one period, we kind of graph a different section of that, right? Whereas the sine function, we start on the midline and graph that kind of section, right? This one we kind of graph the upside down bell, or or a cup kind of section. So that's really what a cosine graph looks like when you graph one period. And again, let's check. Let's take the difference in my ending and starting values. Does it equal my period? 195 minus 15 equals 180. So that makes me feel good, at least that my x coordinates are correct. I'm double checking my amplitude. My max and min values are both the amplitude away from the midline. That looks good. And it's not flipped. So I feel pretty confident that this is the correct graph. All right, so we've got 2. I'm looking at just a few other of these. 3. Let's do 3, because 3 encompasses a couple different things and also gives us a graph that's flipped. And I want to show us one that looks flipped here. So let's first taking a look at this function. This is one of those tricky ones that Cameron doesn't like, where that 2 in front is really a midline. It's not being multiplied. So it may be helpful for you. You don't have to do this, but it may be helpful for you to rewrite it as y equals negative cosine of x plus 180 plus 2. Because that 2 is really being added. It's not a coefficient. It's not multiplying. Or it's not being multiplied with that cosine. So if we take a look at that new function, or at least rewritten function, I can see that my amplitude is just 1. Amplitude's 1. The period, that's also nice, is just 360. Doesn't change. Okay, doesn't change. My quarter period then is 90 degrees. My midline value is y equals 2. The starting value, I'm going to take what's on the inside and set it equal to 0. That gives me x equals negative 180. And is it flipped? It's got that negative. Yes. So again, I'm going to start like I do every cosine and sine graph. I'm going to graph the midline, which is not at 0. What am I doing? It is at 2. So we're going to graph y equals 2 now. Okay, y equals 2. Now, my starting x value is negative 180. If I'm thinking ahead, if I add a quarter period to negative 180, I'm at negative 90, which is going to give me another point to the left of the y-axis. So be very careful and think through spacing out your points. Give yourself enough room to give yourself an additional point to the left of the y-axis here. And if that doesn't quite make sense, you'll see what I mean in a minute. Some of these that start to the left of the y-axis, you have to think a couple points ahead so you can space things out correctly. If you feel like you want to hit pause and try graphing it now on your own and then checking back with me, you can do so. If you don't feel quite as good, why don't you continue along with me now? So I'm going to start at an x value of negative 180. I have an amplitude of 1. Normally you would start the amplitude above the midline, but since this graph is flipped, you might guess we're going to start the amplitude below the midline, which is going to give me a point. Oops, let me do a different color besides black. Besides green. To do black, that's going to give me a point of negative 180, comma 1. Okay, negative 180, comma 1. All right, so that's a min point. I'm now going to go up to a midline point. Add a quarter period. That's going to take me to negative 90, comma 2. I'm going to add another quarter period. That takes me to 0. So 0 should be on the y-axis. And I'm going to go up the amplitude, which is going to take me to 3. I'm going to go back down to the midline and add another quarter period. So that's going to take me to 90, comma 2. And add another quarter period. That's going to take me to 180. Okay, and down to 1 again. So if you were to make this graph, okay, it would kind of look, now this one kind of looks like a bell, not an upside down bell. Okay, this should be symmetrical. Mine looks pretty good, symmetrical to the y-axis. Not perfect, but pretty good. Notice how we have the curves here. It's not a V or an upside down V. This should be a very curvy graph. So make sure when you graph this, it's got curves. There's no sharp turns. There's definitely no sharp turns. And these sines and cosine graphs are all nice and smooth, okay? All right, so that's cosine basically. I mean, if you can do those two we just did, they follow sine pretty much in terms of all the rules. It's just a matter of its starting position above or below the midline. So what do we've got left on this worksheet? We've got problem 4. We've got problem 2. Why don't you guys do this? If you feel up for it, if you feel like you want some extra practice, you can do 2 and 4. But the homework is, let's do worksheet number 3. I think there are only 2 graphs on that. So try doing worksheet number 3 and those 2 graphs, and then come into class with questions, and we will sort it all out. But that's cosine, right? We were able to do cosine in 15 minutes, where sine took us 3 days. So you guys are getting a lot better at this.